Hi, today we'll be looking at a Docker tutorial. We'll first look at what Docker is, and then after that, we'll be looking at what you can use Docker for. And we'll be looking at an example, a live demo. Woohoo! Now let's start with what Docker is. Now, the word Docker comes from the word dock, and dock is where ships come in and exported. So those import and export ships containing containers in them, and those containers have goods. Now, what happens in one container doesn't affect any other container. So that's the whole idea with Docker containers. Isolation of applications. Isolation of applications. Now, this means that we can run a particular app in one container without affecting the app executing in another container. You see this? An example is going to set this completely clear. Now, imagine that one container runs version 1 of your container and another container is running version 2 of your API, and we have two containers which are running clean versions of your database servers. Now, version 1 of your API will contain to the database server that's executing in one server, and version 2 of your API can run connecting to another version of your SQL server. Now, this means that whatever data changes one API makes doesn't affect the data that the other API uses. Now, you can make parallel tests and you can test different versions of your API without worrying that one API will make changes of data that will affect the integration tests of another API. And one elephant in the room is that since we had and we still have virtual machines already, why don't we just use something like Hyper-V or VirtualBox or so to create virtual machines? Why are containers such a new thing, such a thing we're happy about? Now, in virtual machines, we create an operating system, a separate operating system for each and every environment we want. We set it up after the operating system is installed. We set it up. We set up the application, let's say the SQL server, and then it can execute as though it was an independent server. Now, containers reuse the host operating system's kernel for each and every container. So we don't have to create different kernels for similar containers. You see this? So that means we can actually run multiple versions of SQL Server seamlessly on one server. So it saves money as well. Don't have to buy many physical servers or so. So you can have different configurations in different containers. So what are the implications of this simplicity? The implications are that containers launch much quicker than virtual machines because we're not having to launch the kernel and the
Okay, we're
likes.
going to start with
You
our
see,
live demo now. We're going to head over to hub.docker.com where we have predefined images that we can reuse to create our containers. We're going to search for PHP. We're going to look for a PHP image. We recommend official images because they're just trusted and more stable. They usually have more downloads if you check them out. Okay. Now you'll find text. Text are versions of the software. See, now in this case, it will be different versions of PHP, and then I'll tell you extraneous software that's contained inside the image itself that we can reuse in our container. Just going to search for Apache. We're going to use Apache 7.2, which contains the PHP version 7.2 and Apache. Now, if we scroll down in the images Docker file, we'll see the working directory, which is the folder inside the image where the web server is going to serve pages. Okay. So we're going to start by creating our own Docker file that our container is going to extract from or is going to extend. Okay. We're going to create a Docker file that's going to define our container.
just going to call it Docker file. In Windows, if you want to save a file without an extension, just put a period after it. And now that our Docker file is saved, we're going to define it. Now we're just going to instruct it. We're just going to tell it which image we want to import when creating our container. Our image is PHP, and then we're going to put a colon, and then after the colon, we're going to put the tag. You remember the tag, which is the version. So we're going to retrieve that image from hub.docker.com if you don't have it already pulled locally. And then after we've retrieved it, then we can extend it to create our own container that we can run at will, and as many different versions of it as we want, which is quite cool. Now, the next thing is to copy files from our host operating system into the container itself. So we're just going to say take files from our current working directory on our host operating system and then copy it over to the container in the working directory. Let's just look at the working directory again. There we go. It's var www html. So the period there is just the working directory, and then copy it over to the working directory inside the container. Now that's about it with regards to define our Docker file. Now we're going to create a PHP file. This is going to be just your API. We're just going to write a skeleton implementation here. It's something very simple, so we don't focus on that right now. Hmm. Close the tag. You can just call it anything. Okay, now we want to copy this file inside of our container in the web server's root directory so it can actually execute a PHP web server and execute this particular PHP file. So this just prints out a API request. This helps because you don't have to install things like XAMPP and all those, or Apache and run your server, set up your server, set up ports and all those things. This does everything for you. Now, what we're going to do next is build our Docker container from our Docker file. Okay, just going to say Docker build and tell it the directory to build from where our Docker file is located, and all our necessary files are located. The period there is just for the working directory. So build, and then we're just going to give it a name via the T flag. We're just going to call it PHP API. Now after it's built, we're just going to be able to execute it at will. Now that it's building, let's look at the line expose 80 inside our images Docker file. Expose 80 tells the container to make port 80 available to outside environments. See this thing? Yeah, so it's just going to route port 80 out. And then you'll see later when we execute the container that we created, we'll be able to use that port 80 and forward it to another port. Okay, now our container is built successfully. There is the minified or the small version of our hash. Now what we're going to do now is run the container that we just created. Just docker run p, which is the port forwarding. We're first going to specify the port in our host operating system that we want to forward to. Want to forward it to port 8085, and then from port 80. Now we see that our container is executing, and in our host operating system we can see the results that it's actually executing. Now, one consideration is that what if you're still developing and then you saw a bug and then you want to fix the bug? Let's say you modify your PHP file or your API file. If you go to and try to refresh,
it will not reflect the changes. This is because the container has its own version of the files. It copies over the files and doesn't synchronize each and every time you change the files in your host operating system. You see this thing? Okay. Now let's look at a way to actually, let's say you're still developing. Let's look at a way to actually do that. We're just going to press Control C now to stop execution there. We're going to specify the V flag, which is the volume which is going to mount. So each and every time we change files in our host operating system, it's going to copy them over to the container, and then they're going to be in sync. Now the V flag will take the path from our host operating system, the full, it's not relative, it's the full path, and then put a colon and then put the path inside of our container. Okay. Now, if the path in either your host or your container has spaces in between, you just have to put quotations around it. That's it. Then you're just going to execute it. Now we see that it says port is already allocated. This means our container is still executing because we haven't told it explicitly to stop. We're just going to say docker stop with the identifier, with the hash itself of the Docker container so that it can actually stop. Now, Docker PS is going to list all executing containers, and then you see that they're still created. So now we're going to take the short versions of the hashes and stop them one by one just to make sure. Now, why are these created each and every time we run Docker run? It's because Docker run itself actually launches a new version of your container. It's like creating a new container. So the best practice would be Docker start to actually start an already existing container, or just stop it and recreate it. We're just going to stop all executing containers here. I'm going to stop the next one now. And then after stopping them, we'll just run docker rm for removing them. So they're not there anymore. Let's see now. Okay. I like live demos because when you experience such, you can actually tackle them live and then we can resolve such issues. Okay, after we stop them, now we're just going to remove them. I'm just going to use the same command but with rm. Rm is for removing the containers, rmi is for removing images. Now we're just going to run our container again. Aha, no more port clashes or so. Now that it's executing, we're just going to head over, and only if you refresh, wow, now you see the changes applied. But since it's a new container, let's just modify it with another bug fix, and then see if those changes will reflect in our container. Remember, we're not stopping our container. If we refresh, aha, now we see that the changes are reflecting in real time. So when you modify your files in your host, they reflect in your container. Now we saw that without installing any PHP web server, we were able to run a PHP web server with simple lines of code, like 5 lines of code inside our container, and we can launch it at any computer, and it's easy to deploy. Please subscribe, please like. Thank you very much. Please leave positive comments, and thank you.